Okay, so let's suppose we have y equals a sine b x minus c plus d, or a cosine b x minus c plus d. So with this equation, you start with your basic sine graph. Let's just remind us really quick what that looks like. We were just doing it, so I don't think we really have to. So there's your sine graph with your intercepts at 0, pi, and 2 pi, and your maximum at pi halves, and your minimum at 3 pi halves, correct? Okay. So then what are all of these letters going to do to that basic graph? What are all of these variables in here going to do to it? Transform it, correct? And most of them we've already learned about. There's just one new one. So your cosine graph starts here. So it's like you've got this point at 0, and this point at pi, and this point at 2 pi. And then you have this intercept at pi halves, and this intercept at 3 pi halves. Okay, so those are your 5 key points on those two problems, right? Okay, so now let's just quickly review what each of the letters in the equations does. So, just a quick review from last time. A is the amplitude. I put it in the absolute value because the amplitude itself is always positive, right? It's a distance. So always positive distance. Do you need me to actually define amplitude again, or are you good? Okay, so it's like half the distance from top to bottom, right? Okay. What if there's a negative in front of the A? That is a, what would we call that? Vertical flip? Anyway, flips upside down. That's easiest. Okay. Then we're going to skip B because that's the one we haven't learned yet. C. Good. C is the phase shift. And that one goes left or right, the opposite direction. So see, like I said, we're just reviewing. This is the same stuff we just barely did. But you'd be amazed how hard it is to add one more thing if you don't like solidly know these things first. So just make sure we know. So then what does D do? D is the vertical shift. Up or down. And that one is not opposite. It's just if you add 2, it moves up 2. If you subtract 1, it moves down 1. Correct? Okay. So, the new number we need to talk about. B. Do you need this still? B is the number of cycles of the graph in 2 pi. B is the number of cycles, the number of repeats in the graph in 2 pi. So it is going to, you know how we have the amplitude that stretches it this way? This is going to squish or stretch it this direction. It's related to the frequency, yes. Let's talk about that. Okay. So, if B equals 1, and when B equals 1, do we even write it in there? No. So all of the problems we were just barely doing on the examples, b was 1, so it didn't change anything. So if b equals 1, then the period of those graphs was what? 360 or 2 pi, because that's how often it repeated. Correct? Okay. But if b does not equal 1, then the period of the graph, or again, the period means how long one repeat is, then the period will be equal to 2 pi divided by b. So let's think about that. Since b is the number of repeats in 2 pi, let's suppose we have b, the number b equals 2 in an equation. That would mean that there are going to be 2 repeats of the graph in 2 pi. So if there are 2 repeats of the graph in 2 pi, how long will the graph take to repeat once? Now that's a very common mistake, Bryce. Think through that again. Okay, let's do a quick example. So, if y equals sine 2x, I just made b2, everything else is standard, correct? Then that means 2 repeats in 2 pi. So if we sketch that graph and we go from pi to 2 pi like we normally do, this time instead of going up and then down and then back to 0 in 2 pi, what has to happen in order to get our 2 repeats in 2 pi? It has to go up and down and back to 0 in 1 pi, and up and down and back to 0 again before we get to 2 pi. So that the period of the graph is one of those repeats. That's what period means. So how long is the period? 1 pi. So let's look at the formula I just gave you. The period is this formula here. So 2 pi divided by the number of repeats, which is 2. So what happens to the 2's? They cancel and the period ends up being pi. Okay, so then the other thing you need to know is frequency. Frequency is always 1 over the period. So if the period is pi, what would the frequency be? 1 over pi. That means that there is 1 pi of the graph in 1 radian, I'm pretty sure. Frequency for some reason confuses me. Like the unit confuses me. I think the frequency is sometimes done in hertz, which I don't know what that actually represents. Yeah. So that's something I would have to, I don't have that memorized, I would have to research and figure out what that means. Now what if you actually wanted a decimal answer for that? That would be exact, but what if you wanted like, divide it, correct? So take your calculator, go 1 divided by pi and find a decimal. What'd you get? 0.318. The problem with frequency is, like I said, I can't remember what units that would be. This would be radians. The unit for this would be radians, so this would be 1 over radians. So this would be something per radians. I really think it's like 0.3183 parts of a cycle per radian, I think is what it means.